Welcome. Today we're going to be taking a look at the notes worksheet entitled Sum and Difference Formulas Day 2. And so yesterday we just explored the 4 formulas to date. We looked at the sum and difference formulas for sine and cosine. And as you can see immediately on your paper there, we're just going to take a quick look at the sum and difference formulas for tangent. Obviously, if we have those primary 3, then the secondaries, the cosecant, secant, and cotangent, obviously we can work with those as well. But most of our focus will just be on the primary 3. All right, well, let's get started here. So remember the concept is we're combining angles together to create a third, and we're doing that via addition and subtraction. And so here I start out with 2 original angles, angle A and angle B. I combine them together, and when I have that combination angle, that angle has 6 ratios that goes with it, of course. Sine and cosine we dealt with yesterday. And now this would be the other primary one. This would be the tangent ratio. And what's kind of interesting about this particular formula is that the tangent ratio of the combination is all based on the tangent ratios of the original 2 angles. And so it looks like this, everyone. Tangent of A plus tangent of B, and then 1 minus tan A tan B. So again, the tangent of the combination is all based, as you can see, on the various tangent ratios of the original 2 angles. Now, what's kind of intriguing about these formulas is by changing these angles, and the fact of the matter is A minus B is certainly quite a different angle than A plus B, but the formula is actually very, very similar in nature. So same situation, I'm combining it here to create a third angle, in this case with subtraction on the original 2, and it looks like this. Tan A minus tan B over 1 plus tan A tan B. Now we utilize this a little bit, but I will make one deal with you kind of heading forward here. The 4 formulas from yesterday, you just have to know or learn or memorize whatever word you want to go ahead and put with it. But tangent ones I will let go in terms of the memorization, because as it says on your paper, for most of the problems we solve, we're going to use this fact right here. And so I'm going to put this in place in just a second, which allows us to maybe substitute this piece a little bit and not have to memorize a new formula entirely. I think it'll be a little cleaner for us, a little more efficient, and quicker, to be honest. So although these formulas are certainly part of our curriculum here, I think we can find a way to work around it. And so here's what I'm thinking. We all know for any particular angle, the tangent ratio really is just sine over cosine. And so knowing this piece, and you know this already, so I would say you're not memorizing this, for most of our problems, this is going to be the way to go. So as long as the angle measure is the same, tangent, of course, is just sine over cosine. So let's run with that idea. And by the way, the proof for this formula really does come from this idea right here. So, I mean, if you're ever interested in kind of taking a look at it, I can certainly do that with you. There are a couple little interesting steps that you would take after expanding this out and working with it that would produce this up here. So this and this really are the same thing. This, to me, is a little more user-friendly. So the 4 formulas from yesterday, you do have to memorize. These 2 right up here, this one and this one, I can let go. Okay. But there we go. As long as the angle is the same, tangent is sine over cosine. So why don't we do just one using the formulas from above? But as I said, when we really start to apply them in sort of the crux of today's lesson, it'll use this secondary piece right here. Okay? So let's give it a try. So just a nice identity in terms of all in tangent. And I have a variable, so just any real number minus pi over 4. That's our combination. And then it should be equivalent to just this right here. Tangent ratio of the original minus 1, tangent ratio of the original plus 1. Okay, not too bad. This looks like, difference formula for tangent. So all I'm going to do, everybody, is apply that formula right up there and just say it's the tangent of the first minus tangent of the second, and it's a 1 plus tangent of the first and tangent of the second. And again, not really too bad here. sort of a gimme problem for the most part. There's only one way to go there, and that was to use the formula. And then as a result, I see, one variable with the tangent ratio and then one constant with the tangent ratio. And this happens to be our pretty easy one. Tangent of pi over 4, everybody, is just 1. And so you end up getting tangent of x minus 1. And then I'm just going to clean this up pretty quickly down on the bottom, but I get 1 plus, and then tangent of x times 1, because tangent of pi over 4 is 1. So tangent of x times 1 is just tangent of x, of course. And as you can see, that is exactly what the right-hand side is. So tan x minus 1, subtraction order does matter, so I'm glad it worked out that way. Obviously, with addition, the order doesn't matter. So this bottom is, of course, the same as that bottom. Okay, great. So again, just once there, kind of going on through. Let's go to my next board, and let's do just a couple more. And then it's really going to be this piece right here that we'll take a look at. And it'll kind of go to the back side there. I wish I got it all on one side for you, but, well, we'll have to just make do and see what happens. Okay. This example 2 is obviously a very contrived problem, but I do want to explore it for one reason. I'm just curious if you recognize it. So take a look at this and think about the 4 formulas from yesterday. And instead of expanding, what I want to do is contract. So what we did yesterday is we basically took 2 angles and we combined them together to create a third. In this case, I want to kind of, to some extent, reverse that process. Here I have these 2 angles all the way out. What was the original angle, basically? Well, I shouldn't say that. What is the combination of the 2? Okay, well, let's see. Cosine, cosine, plus sine, sine. It should sound familiar. It is definitely one of the cosine ratios of a combination angle. The question is it the sum of the 2, or is it the difference of the 2? And if you remember correctly, opposite symbol for cosine, so this would be 70 minus 40. So that should be that piece up above, and then as a result, this should be the cosine of 30 degrees. 70 minus 40 inside there, that is it. There's cosine of 30. There is the combined piece, I suppose. I don't think I phrased it quite right earlier. So the 70 and the 40 combining together to create the 30. And everybody should know cosine of 30 degrees. And if you remember correctly, cosine of 30 degrees is root 3 over 2. Wonderful. I'm going to go ahead and just confirm on the calculator before we do the next one. We have a little time here. So let me just see. I'm in degree mode. That's good. And I'm just going to type it in, everyone. So cosine 70, cosine 40, and then plus sine 70 and sine 40. Interesting. Again, a very contrived statement there. But let's see what it unfolds. And by the way, just if you remember, root 3 over 2, which is the answer we got, of course, is right around that 0.866 mark. And so when I do this piece, of course, that's exactly what I get. There's your square root of 3 over 2. Now, if you kind of look at it, what to me is sort of interesting about this piece is here was my angle of 30 degrees. In this expression up above, everybody, could I have selected any 2 angles that subtract to 30 degrees? Because this is the difference formula for cosine. Could I have done an 80 and a 50 maybe? 90, 60, 110 and 80? I mean, obviously the sky's the limit. Any 2 angles that would subtract to 30, I could do exactly that expression and get exactly that number. All right, let's see if you recognize this one here, and then we'll do our big one for the day. So sine 65 cosine 25 plus cosine 65 sine 25. So what I see, everybody, is opposite ratios, same symbol. So plus tells me it's going to be a sum formula, and I'm seeing this as the sum formula for sine. Again, that's the only reason I put these on the notes worksheets, is just to solidify it a little further, recognize the combination of 65 and 25 as the sum formula for sine. And so 65 and 25, of course, make 90. And everyone, what is the sine of 90 degrees? It's 1. I won't grab the calculator this time and spend the time on that, but if I typed in this piece right here, would I just get positive 1? Yeah, of course. And again, theoretically, could I substitute any two angles right in here that added to 90, and would it give me 1? Yeah, of course. Okay, good. So those 4 formulas really have to know quite well. All right, now as I said, we've worked a lot with drawing angles and dealing with their particular ratios. Every angle has 6 ratios that go with it. So what we're going to do now is look at 2 original angles, in this case alpha and beta, and then we're going to start talking about the combination piece when we put those together. So I guess here's what I'm going to ask you to do, everybody. Give me 3 coordinate planes, kind of side by side there, as best as possible. And by the way, when you do these types of problems, which of course you're going to have to kind of do, I would definitely draw. Now the third one you won't necessarily need. I'm just going to do that for this problem because I think it's helpful. But certainly, without question, the first 2. So this is kind of poor form on my part, but this is going to be the alpha diagram. This is going to be the beta diagram. And if I remember this problem correctly, I think we're going to combine them only with addition. Obviously, I can combine them with subtraction too at this point in time, but only with addition. So that's going to be my alpha plus beta over there. And I'll have to go a little bit back and forth on my screens. You might have to go back and forth on your paper, but please do so. All right. Well, let's fill in information we know and then go from there. So it says, let sine of alpha be equal to 12/13. I have a positive sine ratio, everybody. Sine is positive, as we all know, in quadrants 1 and 2. I need a little more info to know where to draw my terminal side. And so it says alpha is in between pi over 2 and pi. I'm hoping everybody understands that is the second quadrant. And basically what that means is we're going to draw a second quadrant angle for alpha right up there. And we've talked about this before, that there are an infinite number of ways to go from initial side to terminal side. I'm just going to go the primary way there, from there to there, and I'll just call that alpha. But again, there's really, the sky's the limit when we really think about it. Okay, well everyone, if you would, drop the perpendicular. And so when I see this piece, sine of alpha is 12/13, and you can see why I kind of drew it up here, because my y to r ratio is going to be 12/13. So 12 there, 13 there, that looks great. Now, of course, we all know this. When we're talking about ratios of angles, it's based on the 3 parts, the horizontal, the vertical, and the radius, the direct distance. And so in this case, I'm hoping you understand that we need this piece right here if we're going to start talking ratios. And as a matter of fact, for this problem, we're definitely going to need it. So do a little Pythagorean theorem if you would. You can pause the video if you need. And I'm hoping you kind of have seen this Pythagorean triple before, where it is a 5, 12, 13 Pythagorean triple. Now it just so happens, though, remember, direction does matter. So I believe that would be a -5 right there. And that's a good diagram. There's alpha in a nutshell. Now, guys, let's get our info on beta. So let's take a look. Sine of beta is 3/5. Okay, so same thing, positive sine ratio. So that's either in quadrant 1 or quadrant 2. And beta is in between 0 and pi over 2. So it looks like, in this case, quadrant 1. So everyone, when you get a chance, give me a quadrant 1 angle. Y to r is 3 to 5. As I said, multiple ways to get from here to here. I'm just going to go from here to here and call that beta. Counterclockwise, just from one to the other. Everybody, as you can see, same issue. We do need that horizontal in this case, and you do know it's as a 3, 4, 5 split. So it should be +4 because I'm going to the right. Okay. Now what we're going to do is basically take this angle and add it on top of this angle and get a third angle, which will be over here, of course. Now that third angle, of course, has 6 ratios that goes with it based on its 3 components, but its ratios can be developed from the ratios of the primary 2. All right, let's give it a try. So I'm going to have to go back and forth here. I think what we did is just that prerequisite step of drawing, I think makes this quite a bit simpler and quicker. So preliminary, I guess. That's what I'm going to write right here. Preliminary steps. Ran out of room, so I'll just go prelim. If we're going to talk about a combination, we do know from our formulas on yesterday's notes worksheet that very simply the cosine and sine of the combination angle is all based on both the cosine and sine of the original angles. So I need the cosine of alpha and I need the cosine of beta. So I go back, this shouldn't take us too long, and everybody stare at the diagram for alpha, and what is the cosine ratio of alpha? X to R. Is everyone okay with the negative 5/13? X to R. So cosine of alpha, first order of business, equals negative 5/13. Input is alpha, output is the ratio. We talked a lot about that piece. Input, output. Okay, good. Now, I go on back. We need cosine of beta. So I come right over here, guys, and I just stare at my diagram. Cosine of beta, horizontal, direct, 4 to 5. Positive all the way through. So cosine of beta is 4/5. Same deal, everybody. Beta is your input. And again, as a matter of fact, an infinite number of betas would make this occur. The ratio is the output. Excellent. Okay, everyone. Now we have enough. I think we're ready to roll. So the given information, the preliminary information that we got right here, should bring these three together. And so let's do exactly that. These two, letters C and D, really go from yesterday's. I don't know, we sometimes do sine first, and I would leave it up to you if you want to do sine first and then come on back and do cosine, that's fine. I'm hopefully going to have enough room to pull this off, and I hope you do as well. I might have to come up a little bit here. But here's what I would say. The cosine of our combination is going to be based off the cosine and sine ratios of the original two, of alpha and beta. So what I see is, right away I'm thinking cosine alpha, cosine beta, minus everybody, sine alpha, sine beta. Okay. Now, remember, inputs, outputs. Now, this is what I've seen over the years. Alpha is the input. When I take the cosine ratio of alpha, that is my output. That is my ratio, just one numerical value. And we already solved for that numerical value, everybody. This is just this right here. So I'm going to write that as negative 5/13. That is the answer. So don't try to put a little cosine here. I've seen students do that in the past. Alpha is the input. When you take the cosine of alpha, that means you get the ratio itself, x to r. Same thing, everybody, cosine beta. We have this. We solved for it. It's positive 4/5. Perfect. Minus in between. And then do the same thing. These were given. So let me go back, and I'm going to try to get both in one shot. It looks like sine of alpha was given, everybody, just as a numerical value, y to r, 12/13. Sine of beta, everybody's right here, 3/5, y to r again. So we have those two, and let's put them in place. So sine of alpha, I think I had said, 12/13. Sine of beta, 3/5. There are your four ratios based on those two angles, and we utilize those mathematically in order to get the cosine ratio of the combination of the two, alpha plus beta. I'm going to have to go horizontally here. It's not ideal, but I don't want to run out of room on my board, so we'll see. Anyway, guys, multiply first, subtract second. So multiply, I get negative 20 over 65, and then minus, and then I get to 36 over 65. So just multiplying the fractions there. You could cross cancel, by the way. I've seen students definitely do that. But I think what you're going to want to do is keep it, because theoretically, if we're going to have to subtract the two fractions together, it is helpful if there is a common denominator, which it is. And so now, when I finally do this, I can just keep that denominator. So I would encourage you just to multiply across initially like I did. And then what is negative 20 minus 36? And so that would be negative 56. And that's your answer. That's the cosine ratio for our new angle. Wonderful. Okay. One ratio down. Two more at least to take care of here. Let's see. So everyone, now how about the sine of our combo? Well, the sine of the combo is same thing based on all the cosines and sines of the original. Just the order is different. So the way we laid this out yesterday is sine of alpha plus beta is sine of the first, cosine of the second, keep the symbol, so plus, cosine of the first, sine of the second. Notice, just slightly different order, same numbers, everybody. We can just steal from what's above. So here it is, sine of alpha, we already know. It's 12/13. Okay, cosine beta, right here, everybody, 4/5. Here's my plus. Cosine of alpha, negative 5/13. Sine beta, there it is, 3/5. Again, I'm going to just have to work horizontally here. Do what you're going to do on your paper, of course. And multiply across. 12 times 4, everybody, is 48 over 65. And then over here, everyone, I've got negative 5 times 3, so plus, I'm getting a negative 15 over 65. Wonderful. And 48 and negative 15 added together, of course, should give us 33. So everyone, 33/65, as a matter of fact. 33/65 is your sine ratio for our new angle. Wonderful. Two down. The good news for this one is, rather than having to go ahead and get all the tangent ratios, like the formula suggested, for alpha and then for beta, and applying an entirely different formula, why don't we just go ahead and say, you know what? It's sine over cosine, which we just solved for anyway. So we might as well just use it. To me, it just makes sense to use it. So this is where we're going to bypass the formula that I gave you at the beginning of this lesson, and let's just now use what we have. We just figured out the sine ratio of our new angle. It's 33 over 65. And we already found out the cosine ratio of our new angle. It's negative 56 over 65. All right. And by the way, you can do this so many different ways, but the shortcut version is if they're both over 65, those are just going to cancel out. And you can kind of see this, again, multiple perspectives here, everybody. I get my 33 over negative 56, so this would be negative 33/56. That's perfect. Okay. Now, think about this for a minute, and then we'll continue on. Sine is y over r. There's your y to r. Cosine, everybody, is x over r. There's your x, there's your r. So when we do tangent, isn't tangent just y over x anyway? So y over x. And there it is, y over x. So there are just, again, multiple ways to look at it. I even probably went the slightly inefficient route by even including the 65. But whatever, we got there. All right, good. And let's go a little further. So we've created this combination angle out of the original two. Where the heck is it? And then this piece right here, we're going to just do a little bit together, just using some ideas of inverses. This is, how shall I say it, not required to learn or memorize or anything like that. It's just a way for me to connect. So we'll explore this in a little detail over the course of the rest of the curriculum. But for these issues right here, I won't require you to know how to do this because we don't have enough background to really be as successful as we would need to be. But let's do letter F. Letter F we should be able to do. So it says, what quadrant is alpha plus beta in? Well, let me go back a screen and let's go for it. Let's check our ratios on our new angle. Cosine is negative. Sine is positive. And tangent is negative. So think about that. We have the ratios of our new angle, the primary ones, based on the fact that cosine is negative, sine is positive, and tangent is negative. Where are we, everybody? Quadrant 2. So quadrant 2. Absolutely. It's the only one where cosine is negative, sine is positive, and tangent's negative. It's in quadrant 2. So go back for just a couple secs here, and let's draw this. So remember, the idea is I'm taking this angle measure and adding on this angle measure to create this angle over here. So if I add this to this, it still keeps me in quadrant 2 because this one's a rather small angle. So it still keeps me in quadrant 2. I probably just went a little further, and as a matter of fact, I'll bet you it's something like around right there. Give or take. I think I went a little too low on that, but that's all right. And so what this is basically saying, if you look at the information there, is the R value that we got was 65, and if that's 65, then this is negative 56, and this is 33 right there. So those would be the three components based on our new angle. And then this, guys, would be, I'd be curious about this. What do you think that angle would be? That's what we're going to try to find. And so let's give it a try. So I'm hoping everyone's okay with the drawing. Again, not necessary. I told you this was sort of an optional piece. But I did want to at least put it together visually that here is your x, here is your y, and here is your r. And those numbers match up nicely with a rotation that looks something like this, closer to the x-axis, still in the second quadrant. And that's what happens when you added these two together. Okay, good. Well, let's take a look. So it says find alpha, and we haven't had a ton of experience with inverses, a little bit, but here's what I guess I'll ask us to do. For the alpha, this was the one in quadrant 2 if I remember, so here's what I'll ask. Let's grab the calculator, everybody. And let's see, what was that cosine ratio on the alpha? Looks like it was negative 513. So, and again, I wouldn't expect this too much here. I'll just put this in place. But basically what I want you to do is type on your calculator inverse cosine negative 5/13. And it's all based on the quadrants and how the inverses are defined. That's why I'm choosing cosine here. But essentially I get that right there. In degrees, it just works better in degrees. I think we all visualize better in degrees. In degrees, alpha is 112.62. So I'm going to do this. I'm just going to actually write it in here, 112.62. And the way I did that was by doing a specific inverse. You're just going to have to take my word on kind of how and why that played out. Okay? Now beta actually, because it's in quadrant 1, we do have quite a bit more flexibility. We can do either an inverse sine or an inverse cosine, and I'm going to show you that just so you can see. And again, you can just watch or type with me. If I do the inverse cosine of 3/5, that should give me beta. And that's what beta will be. But as a matter of fact, if I do the inverse cosine of 4/5, because of the way inverses are set up and defined, it should give me the same number. So this was the sine ratio for beta, and that's the beta that would produce it here. This is the cosine ratio for beta, and this is obviously the same angle that produced it. So let's go ahead and call that 36.87 degrees. Okay, so write that in there. Now, everybody, what I want, of course, is what the heck would alpha plus beta be? So, everyone, if you would, grab the calculator, please, and let's add these two angles. So I used inverses to get those angles. And as I said, this is sort of above and beyond. But I like exploring at least sort of the relationships that we're looking at. And so if I actually added those two together, let me see if I have this available, I get something like this. I get about 149.49, looks like. That is what alpha plus beta should be. Okay, that's our angle. And if I go back just a screen or two, just in terms of the way I drew everybody, does that look like 149.49, give or take? Yeah, sure. Okay. There's one last question, and then we'll kind of bring this to a conclusion. It just says, is it consistent with the answers from part C and D? So here's what I'm thinking, everyone. On your paper, let's write this. Now I know what alpha plus beta basically is. I rounded here, but it's not precise. Is that cosine ratio about negative 56 over 65? We'll find out momentarily. And is the sine ratio of our angle, again, I think it's this, oops, 49, sorry about that. So 49 degrees. Is that sine ratio about 33 over 65? Let's see. I'm going to bring the calculator up one more time, and we'll see if we can put a big yes to it that, hey, we did all our work nice and everything was consistent, or didn't work at all. We'll find out momentarily. So here's what I'm thinking. Let's take the input and find its cosine ratio. So cosine 149.49. And we get that decimal right there. Is that roughly negative 56 over 65? Now remember, I rounded my angle here a little bit, so it might not be perfect. But is it equal to that? Pretty close. Look at that. Here's the angle that I found when I took its cosine ratio. Is it consistent with our answer from part C? Absolutely. Let's try the sine. So I'm going to type in sine of that angle, and I'm going to get that right there. Is that consistent? I mean, I did find the sine ratio of that combination. Hey, everyone, it should be exactly 33 over 65. And because I rounded my angle, this is not going to be precise, but is it pretty close? Sure. Look at that. So, is it consistent with the answers? Yeah, undoubtedly. The drawings, me finding the two original angles and adding them together, combine them, and I got that. Are the ratios equal to what we got? Sure. Okay, good. Again, if you can go through part F, I think you're really on target with this. But I would encourage you to draw, label. We've been doing it now for several weeks, and I'd encourage you to continue that process. Okay. Well, thank you very much for listening, and let me know if you have any questions.